this video, I'm going to demonstrate a few basic strategies for getting started on a 3D massing. Those will be extrude, scale, and loft. Scale to make a taper, scale and loft as a bulged form, and twisting and lofting. And then I'll go over briefly how to make more complex forms, the idea of using a Boolean difference as an example method. So we're going to start with the basic polygon that I showed in the Getting Started on 2D Part T video, which has an adjustable radius, an adjustable number of sides, and we'll leave that pretty set for now. And again, there's this grid that can be formed along that has a variable number of spokes, as I call them. So from there, we can do some, just with that polygon shape, we can start to do, to generate really quickly some three-dimensional massing. So this is taking a surface all the way back here from just that basic polygon and really just extruding it. So there's an extrude extrude curves and surfaces along a vector node, so we'll use that. And for this base, it brings in some surface, and for the distance, direction, you'll need a vector, which is the direction that you want to extrude, and a factor, which is, for this example, extruding in the z direction, is just the height of our mass. So this is, you can get the, this unit z will be this extrude direction. And just as for your information, there's also one for x and also for y, and if you needed to extrude in those directions for some other models in the future. So let's see if we can cut. So plugging that z into the direction and a number slider into the factor, we can really simply get an extruded solid. So to get slightly more complicated forms, down here we've used this scale non-uniform node, which scales that copied again. It's used it scales a copy of this original polygon from the beginning, and so we can adjust the amount that we're scaling that polygon, and then we're going to move that that copied polygon in the z direction, and this again will determine the height. So if we just turn off this, all we need for lofting is two curves. So we'll put both of those curves into here, and remember to hold the shift so that you get that little plus sign when you're putting in your second curve, and we can get a lofted shape that is now adjustable by this scale factor, so how much it tapers, and also the height. And just to cap that off, use the cap node, and now we have a solid looking mass. So then a slightly, so this is the taper formed. And then a slightly more complex but more interesting way of doing a similar thing is to get this form that is kind of a bulged form. And again, it's a similar method. We are scaling a same exact polygon, moving that up. So we can adjust the scale factor of that, the first copy and the height, and then we just copy paste all of that again. So I have should change this to be scale factor 2 and height 2, and now we have another polygon up there, and that has its own scale factor, its own height. And then, so all we want to do is use this merge to bring together these three curves, and we want to do them in the correct order. So in the merge node in D1, we want to be the first curve, which is the original polygon up here. Then into the D2 slot, we want the middle polygon here. So connect that to D2, and then the 3 will be the third, so that it lofts in the correct order. And then plugging that into loft, we get this kind of bulged form. And again, I capped that to give us a solid. And I'll just turn off all of this to kind of show the adjustability of this. We can make the bulge even more or less. Actually, can go inverted. We can do the same with the top. We can go kind of splay outward or come almost to a point. And the height can change as well. And adjusting the height of this will kind of make the bulge go up and down on that form. Some really interesting possibilities. We can even make this go kind of inward if the height of the second one is lower. Using this loft with multiple curves is really powerful, really complex shapes possible. So that's another version of scaling lofting. And then this last one here is twisting. So we're going to the first step will be to rotate that original polygon by some angle. So that's adjustable. And then to move that up in the Z direction to give us some height of the mass. Lofting that. Capping to give us a solid. And now we can adjust both the height of that form as well as the twisting factor. So then, just as a quick example of some even more complicated geometry, we can think about any of these methods being plugged into the Boolean operations. So for this one, I'm just making a really quick sphere. The sphere wants a center point and a radius, so that is adjustable. I can move the sphere around, make it larger, smaller, higher, really locate it wherever I'd like it. And then when they're intersecting, I can use this Boolean difference node, then turn off the sphere, turn off the original extrusion. I'm going to turn off this original polygon also. And now we have a much more complicated geometry that is still adjustable. I can still move around that sphere, and it will change the Boolean difference just in the radius as well. So pretty complicated, but forms just generate from a couple of nodes. And again, any of these other methods could be linked to this Boolean, and we could do multiple Boolean differences on top of each other to get really complicated forms for our 3D masses.